Now, in our daily life, we encounter many examples of chemicals. So suppose you take a bottle of drink, somebody passed you, and you want to ask yourself, what kind of chemical is present inside? How do you know that that substance does not contain any petroleum or some form of alcohol that's safe to drink? We have to conduct some tests. People may say that we can use boiling point, melting point. But what if we do not know the boiling point or melting point of a new substance, something unknown, or something that's very complex? Here, you learn something called the nuclear magnetic resonance. In short, for chemists, is NMR. Nuclear magnetic resonance. It is a very popular analytical tool for chemists, for organic chemists, for all chemists. So in short, NMR. Now, and for your syllabus, I'll be teaching you how do you apply this technique in organic chemistry. So to be specific, we'll be analyzing a proton NMR, a hydrogen nuclei with one proton and no neutron. So this is what we look at. There are a few principles in analyzing a molecule using NMR. The four key elements would be, the first, the number of hydrogen environment. Number two, the integration ratio. Number three, the splitting pattern. Or what some people call the N+1 rule. And lastly, chemical shift. I'll be going through with all of you one by one slowly, and we'll start off with number one first, the number of hydrogen environment in a molecule. Now let's look at this molecule here. You know this well, this is your propane, right? C3H8. How many hydrogen environments are there? So for a start, I will draw it for you. All the hydrogens in this molecule. I see two kinds of hydrogen. One set, and two sets. Somebody may ask, why are these three the same as the other three? Because here I could draw a symmetry line that reflects these protons onto the other protons. Or you can use your two hands again, your fingers up, and you see, for these to be equal, they must go bond by bond and reach the same place at the same time. So, suppose they are the same, okay? So you go with the bonds. One, okay, it's a carbon, same. And two, now they meet. So this means that these two are of the same environment. And since we know that all these three hydrogens are connected to the same carbon, these three are equivalent, they are the same. And these three are the same. And since these two are the same, so all these six are in the same environment. It is quite obvious that these two protons are of different environment compared to the other six. How do we know so fast? Because if I zoom into this proton, suppose you are this guy, all right, and you are connected to a carbon that has one hydrogen and two other carbon, which obviously is different. If you are belonging to this hydrogen and then you walk, okay, I connect to a carbon with another carbon and two hydrogen. So you see, it's like playing board games. So you just go square by square and then you notice that, oh, your paths are different. And that's how you tell in this molecule, propane, there are two different environments. I will circle them. So these are environment A, and these two belong to environment B. Two environments means in your NMR signal, this is where the graph looks like. At 0 ppm, which is what we have a reference here called TMS. Then for propane, I will have two signals. There's two main signals. Okay? So this tells you that in that molecule, there's only two environments of protons. Let's try one more example. This is 1, 2, 3, 4. It's a butane with a methyl group at the side. So let's see, how many protons are there? 3 from here, 3 from there, 1 over here, 2 from this carbon, and 3 at the end. And how many different environments are there here? These 6 are the same because now you walk carbon and they reach the same atom. So these 6 are the same. The other set come from here. This solo hydrogen is very different from the rest because it is the only hydrogen that connects to a carbon with no other neighboring hydrogens. You see, it's all carbon. And the next set of environment will be from here, this set. And lastly, this terminal methyl group here, that set. So, environment A, environment B, environment C, and environment D. Now, one question. Some people may think, hey, isn't A the same as D? Let's do some verification. Again, suppose they are the same. So you use a finger and start with the H's on both sides. Bond by bond. Let's go. Okay, one bond, yes, I'm reaching a carbon that has 2 other protons. This works fine. So I go one more. All right, so look at my right finger. This carbon connects to a carbon with 2 hydrogens, whereas my left finger says it is a carbon connected to 2 hydrogens and 1 hydrogen. So that means my 2 fingers are of different environment, which leads back to them to think that these are of different environment. So if you look at the NMR spectrum for this molecule here, it will show you how many signals? 4. A, B, C, and D. So 4 signals separated.